So this video is just trying to give you guys a sense of how you can connect an embedded function or a composite function to the function. So normally we have an x that is connected directly to a y, and as x changes, y will change. Okay, so that's essentially how functions work. But when we have an embedded function, we have a function where the x will affect an embedded function, and then that embedded function then it affects the y. Okay, so if I put in an embedded function here, okay, so here's another embedded function. So this is an intermediate function that connects the x to the y. Okay, so this would represent a composite function. For example, this could be f of x. This would be this is f of g. This is g of x, and this is our x variable. As the x changes, it's going to affect the composite or embedded function, which then affects the y function, or the output function. Okay, so we can, as we connect these together, we can connect the x and the y together, and you can see how, x and the u, so as x changes, u will change. And then as we can see that when we have a function u, as u changes, okay, we can make the y wheel change. Okay, so I can't make this actually change, but you can imagine as I turn this, the y will change. So what's going to happen when I have this embedded function acted on by the x? So when I connect this, you can see that as the x changes, it changes the inside function, which then itself changes the output function. Okay, so this is how it's acting. And what I really want to do is I want to look at the actual rates. So if I change the rate, or how fast it's working. So if I change x a little bit, it's going to have an overall effect on the y wheel. If I change u, right, that's going to have an overall effect on the y wheel. Okay, so again, I can change x. If I make x really big, you can see that the y wheel is going to change really quickly. If I make y small, it's going to change even faster. Or I can make y really big and it changes the same rate. Okay, so essentially we want to start looking at rates at some point. And as the rate of this changes, it's going to affect the rate of this, which then affects the rate of the overall function. Okay, and I wanted you to notice the mathematical relationship between these two. So first of all, just understand how the rate of this will affect the rate of this, will affect the rate of this. So change the speed of the wheel. If I slow x down, okay, or I can speed x up, you can see that the rate of the x wheel will affect the rate of the u wheel, which then in turn affects the rate of the y wheel. So these are the rates. So if I actually, I'm just going to back it off a bit, if I actually look at the rate, so this is the rate of how x changes with u. Okay, so this u is going to go around twice for every one time this goes around, just because of the radius of those wheels. And this y, I'm just going to change a little bit. Let's make it a little bit nicer number there. Okay, so one change here is going to affect about 0.625 change on the y. Okay, so the change in y over the rate of change is 0.625 for every one circle. This is going to go around 62.5%. For every one circle here, the u is going to go around 200%. And I want you to notice something about these two rates. This is the rate of change of u with x. This is the rate of change with y with u. And if I want to know how the y changes with the x, we can actually just multiply these together. And algebraically, what happens is actually the du's cancel out, and we end up with dy by dx. And notice here that if I reveal the overall change, the overall change is for one of these, the y wheel turns 1.25 times. Okay, and that is a product of those two rates. I can make this wheel the same size here, and this is changing at a rate of 2 times for every one of these. This is changing at a rate of half for every one of these. Okay, and you can kind of see that the X and Y wheels are changing, in fact, at the same rate. It's a 1-to-1 ratio. And that's what we get when we multiply these two rates together. 2 times 0.5 gives us a 1-to-1 ratio. And you can kind of see that through the gearing of that. And sure enough, as X changes once, Y will change once as well. Okay, and we can see that these rates affect each other. And as we change the rates, okay, by changing the size of these circles, you can see that the overall rates change relative to each other, which is, in fact, these rates change as a product of each other. And algebraically, the rate of change of y compared to the rate of change of x, well, we can just do that by multiplying these together, and you can see that the du's cancel out, and the products give us the change of the y wheel compared to the change in the x wheel.